We are now on to the third chapter, Equations and Inequalities. Again, you probably know this from GCSE, so you can skip this one and move to the next subtopic as you wish. So let's get started. I give you two equations and I give you two unknowns. So what are the unknowns here? X and Y, two unknowns. You see what's going on, you need to solve for them. How do we do that? The first method is elimination. I want to multiply either expression number 1 or expression number 2 by something so that I can add or subtract the equations to eliminate x or y. You'll see what I mean. I'm going to multiply expression 2, which is this one, by 3 to get 9x minus 3y equals 69. So I multiplied top and bottom by 3, not 2, by 3. And what I got was this. 9x minus 3y equals 69. 2x plus 3y equals 8. This is just from the first equation. That just comes down without any problems. And then we add the two equations. Why do we add those two equations? So that negative 3y and positive 3y cancel out. So if I add those two equations, I get 11x equals 77. And I just simply get x equals 7. Now that I have x, I can plug back x into any of those equations to get my y. I go down and you see when I substitute y back in, 9 times 7 minus 3y, I think that came from this equation. I put that back in. 9 times 7 is 63. Negative 3y goes to the other side. 63 minus 69. This is basic manipulation. Y equals negative 2 and we are done. This is your basic elimination method. Now we look at the substitution method. Substitution method is involving such thing. So you're making one of the variables a subject, one of the unknowns. In this case, we'll make x the subject in equation 1. So what do I get? I get x equals 11 minus 3y. Simple enough. We just took 3y to the other side. And now I'll substitute x in expression number 2. So here I'll put in x and I'll put in 11 minus 3y. I go down. So what does this equation become? 4 times 11 minus 3y minus 5y equals 10. Simple. Let's go down further. 44 minus 12y minus 5y equals 10. That's just simplifying the expression. 34 equals 17y, y equals 2. And we can finally get our x from the equation above, which was this one right here. I put y equals 2 in there to get x equals 5. And that's literally your basic linear substitution equations or linear simultaneous equations. Now, we'll move on to something slightly trickier, and that's quadratic simultaneous equations. What happens here is you get one equation which is linear. Linear means the highest power is 1. Like this, the first equation. And the second equation is a quadratic. Quadratic means the highest power is 2. Notice that we don't have a standard quadratic, which is ax squared plus bx plus c. This is not a standard quadratic. This is a quadratic involving an xy term. It's still a quadratic, but not a standard one. For intuition, I have drawn its graph. It's the one in yellow here. So you see it's more like I think it's called a hyperbola. So for intuition, I have drawn the graphs. The black one represents the first equation. The yellow one represents the second equation. And it's not a standard quadratic. I hope you can see that. Now what we are going to do. Here only substitution works. We can't try to eliminate a variable because this is not a linear equation. It's a quadratic equation. You'll have to make x or y the subject and plug it into this equation. So I'm going to do this one with you right now. What am I going to do? I think it's easier to make x the subject. So I'm going to say from 1, and you don't need to write this formally, but I would. From 1, x equals 3 minus 2y. That's explanatory. And I'll just plug it into 2. Plug into 2. What do we get? We get 3 minus 2y whole squared plus 3 times 3 minus 2y times y equals 10. Simple enough. I should have scrolled down. Simple enough. And now we can do the rest of the manipulation. So the manipulation has been done. We have expanded the quadratic. There is the steps if you want to see. And y, you get two options for y equals negative a half or y equals negative 1. With each y value, there will be an associated x value. So if I plug y equals negative a half back in, I will receive x equals 4. If I put y equals negative 1 back in, I'll receive x equals 5. So the final solution, you are safe to write it in this coordinate form, where this represents the x value and this represents the y value. So you'll get this, and this is the right solution. So this is 3.3, simultaneous equations on graphs. It really wants you to understand two concepts. One is that if you have a line and a quadratic, you can draw them as I have here, and you can just read off the solutions, in this case like these. Sure, this is one concept. The other concept is one which will be demonstrated with an example. This diagram is irrelevant to this one. You can still draw a diagram for this, but okay, let's get started. Let's read the question. Y equals 2x plus 1, which is a line, intersects kx squared plus 2y plus k minus 2 equals 0 at exactly 1 point, and k is a positive constant. And we are asked to find k, and we are asked to find the point of intersection. Yes, you could draw this on a graph, but let me just do one more thing. When it says at exactly 1 point, notice this is possibly a quadratic. It's not a standard quadratic, it's a non-standard quadratic. But whenever you hear the term exactly 1 point or exactly 2 point or exactly 0 points, you should be thinking about discriminant. What is discriminant? B squared minus 4ac. We know this from chapter number 2, quadratics. If there is only 1 point of intersection, that means there is only one solution to the quadratic. That means b squared minus 4ac is equal to 0. It's not greater than 0, neither is it less than 0, it is equal to 0. So this is what we are going to do. A question arises, can I even get a standard quadratic? Because discriminant only applies to a standard quadratic, which is of the form ax squared plus bx plus c equals 0. Can I create a quadratic like that? The answer is, in this case, I absolutely can. And it's not very hard to see how we can do that. We will just use substitution, which we learned in topic number 2, quadratic substitution. So I'm going to get started with the solution. Let's say I'm going to write the equations again for simplicity. 2x plus 1 and kx squared plus 2y plus k minus 2 equals 0. Luckily, I already can substitute because I already have y, which is right here. So I'm going to substitute 2x plus 1 into y. What will I get? I'll get kx squared plus 2 times 2x plus 1 plus k minus 2 equals 0. Now can I simplify it? I absolutely can. I get kx squared plus 4x plus 2 plus k minus 2 equals 0. The 2 and 2 nicely cancel out. So what am I left with? I'm left with kx squared plus 4x plus k. And k is a constant, so no problems. And now I just need to compute the discriminant, and I need to set it equal to 0. So need b squared minus 4ac equals 0. And how will I do that? Very simple. What is my b? B is 4. So that would be 16 minus 4. What is a? A is k. So I get 4. So I get 4k. What is c? C is also k. So I get k equals 0. This is essentially saying 16 minus 4k squared equals 0. What does that mean? Very simple. 4k squared equals 16 and k squared equals 4. This implies k equals plus or minus 2. I just take square root on both sides. But if we go back to the question, what does it say? K is a positive constant. Positive means greater than 0. So I will read k equals negative 2. So k equals 2. This is a very important statement, else you'll lose a mark. They want to see you rejecting k equals negative 2. Sorry for my handwriting if it's bad. I'm trying to explain a concept. Just hope you catch that. So k equals 2 is our solution. We have thus found part A. The next part says we need to find point of intersection. You could draw a graph. In this particular case, you don't need to. And it's how you would draw the graph because you have a 2y term in there. So I wouldn't bother for now. Let's look at how to solve part B. Alright, so part B says that we need to find the point of intersection of these two equations. Notice we have found the value of k, which we got as 2, right? Positive 2. So I'm just going to plug k equals 2 into the quadratic which I got here, right here. To plug it into this quadratic. So what will I have? I'll have something like, it's written in notes, 2x squared plus 4x plus 2. So let me use a different colored pen. 2x squared plus 4x plus 2. That's just by plugging k in. 2x squared plus, so that comes 2. I just plug it down and that's what I have. And now I just need to solve it to find the point of intersection. I think this is equal to 0 if my notes are right. Yes, this is equal to 0. And now let's solve it. Notice I can divide both sides by 2. So divide by 2 both sides. And what do I get? I get x squared plus 2x plus 1 equals 0. This is my favorite quadratic expression because this is easiest to factorize. It's just x plus 1 whole squared. And rightfully so, you realize there is only one solution here, which is x equals negative 1. There is only one thing which will make this bracket 0. So x equals negative 1. We got it. And now we just need to find the y value. Don't stop at x value. That's a common mistake. You need to find the y value for it as well. And we'll plug y somewhere. We have the equation y equals 2x plus 1. We are just going to plug it back there. So y will be 2. So y equals 2 times negative 1 plus 1, which is just negative 2 plus 1, which is just negative 1. So your answer is x equals negative 1 and y equals negative 1 as well. And you are done. That's it. That's all this concept is. 3.4 Linear Inequalities. We are required to find set of values of x for which 5x plus 9 is greater than or equal to x plus 20. Now, there is one rule with inequalities that you guys should know. That if I multiply both sides of the inequality, or if I divide both sides of the inequality by a negative number, then the inequality flips. So multiplying slash dividing by a negative flips the inequality. So if I were to say, an example would be, let's say if I say 6 plus 6 is greater than 10. That would be right because 12 is greater than 10. Suppose I multiply both sides by negative 1. What do I get? Negative 6 plus 6. I don't know what the sign will be and I'll have negative 10. Now I see this evaluates to negative 12. This evaluates to negative 10. But I see that negative 10 is greater than negative 12. So as you see, the inequality sign has flipped. So multiplying or dividing by a negative flips the inequality. All right, here it won't be required because it's a relatively simple question. I'm going to use a darker colored pen. So to find all the values, we're going to make x the subject first of all. I'm just going to bring x to the other side. I get 4x is greater than or equal to 20 minus 9. This implies 4x is greater than or equal to 11. That means x is greater than or equal to 11 over 4. And that's all you need. So in set notation, you would write x, then you would write 2 colons because that means x such that x is greater than or equal to 11 over 4. That's just set notation. You'll get more familiar with it as we progress. All right, let's look at a slightly harder example. So now we are required to find the set of values of x for which 3x minus 5 is smaller than x plus 8 and 5x is greater than x minus 8. So we'll deal with both inequalities one by one. Let's start with this one. I'm going to change the color. So what do I get here? 3x minus 5 is smaller than x plus 8. I take x to the other side. It gives me 2x is smaller than 13, right? All good. That means x is smaller than 6.5. Pretty simple. So that's my first inequality I need to deal with. And then I go the same to the other side. I'll take x to the other side. 4x is smaller than negative 8. That means x is smaller than negative 2. I have not divided by anything. I divided by 4. So I have not divided by anything negative. So inequality stays. Now, on a number line, it's helpful to draw a number line here to see what's going on. This is my number line. I only care about the, let's say, this part. So this is my 0. This is my negative 2. and this is my 6.5. These are the only values I care about. They are my critical values. Now I need x is smaller than 6.5. So anything that goes from here to here, I'll put an open dot because that means 6.5 is not included. And I need everything that goes from here onwards because I need x is greater than -2. All right. So I'll put an open dot here as well. Now I need to find where the overlap is. I see the overlap is within this region. This is the region, right? So in set notation, how can I write? I can say x such that, I'll scroll down, x such that -2 is smaller than x and is smaller than 6.5. It's the exact same way to represent these two inequalities. Hopefully you understand. Sometimes a diagram helps in this case. All right. So now we are looking at quadratic inequalities. Now this is slightly harder than linear inequalities. We have to find all the values of x for which 3 minus 5x minus 2x squared is smaller than 0. Now this is where we will definitely need a diagram, but not just yet. We need to find critical values. Critical values will be where this expression is equal to 0. You'll see what I mean. So I need this expression equal to 0 for now, and then I'll check when it's smaller than 0. All right, so let's try to solve. Since I have a negative coefficient for x squared, which is -2 right here, and I don't want negatives, I want positives, that's easier to deal with. So I'm going to multiply both sides by -1. When I do that, the inequality will flip. So I'll get something like 2x squared plus 5x minus 3 is greater than 0. So the question has changed. Well, not changed, but it has been written into an equivalent form that I need to find same x values where this expression is greater than 0. Because I just multiplied both sides by -1. So let's continue. I'll get a different colored pen. How to do that? Well, let's try to factorize it to 0. I think I see it. So 2x squared, let's say plus 6 minus 3. And let's say I'm going to do this equal to 0. I get 2x, x plus 3, minus 1, x plus 3, equal to 0. If you're wondering how I did this, this is in factorization in chapter 2 and a little bit in chapter 1. So you can watch those videos and there it's covered. So 2x, x plus 3 minus 1, x plus 3. And I will take this out. So 2x minus 1, x plus 3 equal to 0. What does that mean? Either x is equal to a half, which will make this bracket 0, or x equals -3, which will make this bracket 0. So that's what I wanted. But the question is not done. Notice the question is that now I need to find the values where this statement is true. I need all the values where it's greater than 0. But I can sketch the quadratic to see what's going on. So this is my little sketch. My critical value is x equals -3. That's my x-axis. That's my y-axis. That's 0. And here x is a half. Now, since the coefficient on x is positive, I know this is a smiley face. So it intersects the y-axis somewhere down here, then it goes back. So it is a smiley face, I know. But where is it greater than 0? It is greater than 0 when I go towards the right of 1/2 or I go towards the left of -3. Do you see? So now how will I write this in set notation? I will write x such that, open curly braces, x is smaller than -3. That's what I want. Did I want equal or did I want greater than or equal? No, just want. So how will I write this in set notation? I'll write this as x such that x is smaller than -3. Union. Union means either this or what I'm going to write next. X is greater than a half. So this is how I write this. And hopefully that's clear. I needed x in either direction. This is where the inequality is greater than 0, or is it on the right of 1/2, right? So that's what quadratic inequality is. So this is a slightly different example. I'm given the equation 6 over x is greater than 2 and x is not equal to 0. If I were not given the constraint x is not equal to 0, then I would have to probably sketch. But here I can even do it algebraically. And the trick here is to multiply by x squared. Now, why am I multiplying by x squared and not x? Because I don't know if this x is negative or positive, right? If I'm multiplying x on the other side, x can be negative or positive, right? So I don't know if I need to switch the inequality or not. What I do know is that x squared is not equal to 0 since x is not equal to 0, and x squared will always be greater than 0 because a squared term is always non-negative, but it cannot be 0, so here it will be strictly positive. So I can easily multiply both sides by x squared without having to worry about inequality flipping. So that's what I'm going to do. Let's take a different colored pen. Let's say, I don't know, let's say red. Randomly choosing. So what do I get? I get, pen just stopped working. 6x is greater than 2x squared, right? What am I going to do? I'm going to make this a quadratic. So I get 2x squared minus 6x is smaller than 0. I've not really flipped the thing. I just took 6x to this side and then I just rotate the other way. Hopefully you understand that. Right. So what am I going to do now? I can find my critical values, which is, in this case, it's actually very trivial. I'm just going to factor out x. That gives me 2x minus 6 is smaller than 0. So my critical values are x equals 0 or x equals 6 over 2, which is equal to 3, right? And yeah, implicitly, I have said this equal to 0, implicitly. Now, how do I find the values? I just need to sketch this. Is it a happy quadratic or a sad quadratic? It's a positive coefficient, so it's a happy quadratic. My critical values are 0 and 3. So there is my sketch. And what do I need to find? Where it's less than 0. So it's less than 0 when it's actually within this region. So x has to be between 0 and 3. So how will I write this in set notation? I will say, very simple, x such that 0 is then x is smaller than 3. And that's literally your solution. Let's look at 3.6, inequalities on graphs. We are interested in finding values where one function achieves a higher or a lower value than another function. In this case, the functions of our interest are f of x and g of x. Now we'll see two graphs. The one in blue is y equals f of x. The one in orange is y equals g of x. Probably you can tell. I have zoomed in. Now, I've marked the area in blue or purple, whatever you're going to call it, where f of x is smaller than or equal to g of x, and in orange is the area where f of x is greater than or equal to g of x. So, for example, if I were to take the value x equals 3, 3 is somewhere here, right? So it lands in the blue area. So that means at x equals 3, f of x is smaller than g of x. Okay, simple enough. But if x is after 5 or before 2, then f of x is greater than g of x, as you can probably tell. To confirm this, you can draw a vertical line. So suppose I draw a vertical line here. I see that it touches g of x first, and then it touches y of x. And we can tell that y of x or f of x is higher up, right? So at this point, f of x is greater than g of x. Hopefully it's clear. You just need to see which graph is above the other one, and then you can tell which function achieves a higher value. Hopefully that's straightforward. Let's look at some examples. Let me zoom out a bit. Let's look at example 2. What is it saying? Line 1 has equation 12 plus 4x, okay. Line 2 has equation, L2 has equation y equals x squared, so that's not a line, that's a quadratic. The diagram shows a sketch of L1 and L2 on the same axis. Yes, it does. Find the coordinates of P1 and P2. So what are P1 and P2? They are points of intersection, as I can tell. And, oh yeah, find the coordinates of P1 and P2, the points of intersection. Right. So let's do that. And the second part is write down the solution to the inequality. Fine. Let's find the points of intersection. That's just saying equate these two, right? And that's what we exactly do. If I zoom in a bit, we see x squared equals 12 plus 4x. Okay, good. Then we just take terms to the other side. Nice. We factorize. Nice. We know that. We get the values. Excellent. And we just plug these values back into y equals x squared. You can plug these values here to find the values of y. If you plug in x equals 6, you get y equals 36. That is absolutely right. And then when you plug in x equals -2, you get y equals 4. Excellent, right? We can now identify which point is which. We can tell that x equals 6 has to be this point because it is on the positive side of the x-axis, right? So that's it. And then we have achieved this, and now we just need to find where is 12 plus 4x greater than x squared. Now let's do that with the help of the graph to practice what we just learned. So we are going to find where 12 plus 4x is. So 12 plus 4x is this line. And I need it to be greater, right? Yes, I need it to be greater than x squared. I can tell that within this region, if I do the vertical line test, at any point within this region, I see that the blue line achieves a higher value than the quadratic. So 12 plus 4x is greater than or equal to y equals x squared between P2 and P1. So P2 was -2 and P2 is +6. So they are the x coordinates. And so you can see what the solution is. Whenever x is between -2 and 6, we get 12 plus 4x is greater than x squared. We can now read it off the graph. Pretty easy, right? Okay, let's continue. Now this is exercise 3F. So I'm going to move on to the next subtopic, which is regions. Now you can read what is being said here, but I'm going to explain it in my own way. It says y is greater than f of x represents the region below this. So if I go down there, it's below y equals f of x. This region is greater than y equals f of x because it's above the quadratic. So this one is greater than or equal to, and anything below is less than or equal to. But I'll explain it in a better way in my diagram below. So ignore that if you want, or don't ignore it if you want. Okay, let's look at some rules. You don't need to read this. You can if you want, but no need. Just look at what I'm going to tell you. If I have the variable of interest as y, then if I see this sign, I want to understand it as below. If I see this sign, I want to understand it as above. For x, if I see this sign, I want to identify it as left. If I see this sign, I want to identify it as right. What do I mean by that? Let's look at an example. So if I see y is greater than or equal to -2, let me zoom out a bit so that you can see. If I see y is greater than or equal to -2, that means y is above -2. Y is above -2. I'm going to write above for you here. If I see x is smaller than 5, I want all the x values to the left of x equals 5. Left of x equals 5. Then I see the smaller than sign. So y is smaller than 3x plus 2, smaller than or equal to. So I need it as below, as you can probably tell. Of course, if it's less, then it has to be below, right? So hopefully you're getting the hang of it. And then finally, I see x is greater than 0. That means I need it to the right of x equals 0. Okay? Now let's look at what the question is saying. The question is saying, okay, I didn't mean to erase that. The question is saying, find the region that satisfies all these inequalities. And they claim that this is the region R which does the job. Now let's see if it follows our rules. In this region, are we above y equals -2? Are we above y equals -2? Because this meant above, right? Did I write above or below? I'll have to see in the video. I meant above. I hope I wrote above. So here y is above -2. Are we on the left of 5? Are we on the left of 5? Here is your 5. So yes, we are on the left of 5. So that's satisfied. Are we below 3x plus 2? That's the 3x plus 2 line. Are we below it? Yes, we are. Are we on the right of x is greater than 0? This is your x is 0, so we are indeed on the right of it. So we can see that this region satisfies all the inequalities, and that's really what we want. Now, one more thing here is, I think you should read this for a second. You draw a dotted line if you are not included, and you draw a solid line if you are included. So let's say if I have x is strictly greater than 0, this is what I'm talking about. I want to draw a dotted line. I don't know if you guys can see, but the line here drawn is dotted, both on the y-axis and right here. Both are dotted lines because we are interested in x's strictly greater than 0. If it was greater than or equal to 0, you would put a solid line. But here, since it's strictly greater than 0, you put a dotted line. Now, when you have y is greater than or equal to -2, that's the first equation or first inequality. It's saying -2 is included. So we are interested in a solid line. I'm going to clear the graph so that you can see what we have drawn here. Right on -2 is a solid line, isn't it? It's not a dotted line. It's a solid line, as you can tell. So hopefully the concept is clear. If you are below a line, you are less than it. If you are above a line, you are more than it. Exactly. This is literally what it's going on. Do some questions and you'll get a hang of it. Let's look at another example. So on the graph paper, shade the regions that satisfy these inequalities. I think I should do it for you. So we first draw the quadratic. Well, I think that's easier. You can draw the line first. It's really up to you. Y is greater than x squared minus 3x minus 4. Now, how will we draw this? We'll first draw y equals x squared minus 3x minus 4. Of course, that's what we are going to draw. And we'll check the area above the quadratic. So above this quadratic is all this area. All this area. And then we draw this line. This is just an equation of a line, but in a different form. Y equals mx plus c. But we just have y. We just have 2y instead. That 2 should go here, should get divided. But yeah, it's equation of a line. Hopefully you can tell. We draw the line as dotted because we want strictly less than that, of course. So when I want something strictly less than that, I'm going to change my colored pen. And I know I'm looking at everything below this line, everything below the line. But what is the area that satisfies both of them? It is the shaded area, R. Hopefully you can now understand it. I was interested in this area. So the overlapping bit is the area of interest. And guys, that's your chapter done. This is the mixed exercise. I would love for you to complete the mixed exercise because this will actually test your conceptual knowledge. In fact, you should do all the exercises, at least the tough questions from each exercise. But mixed exercise is an absolute must if you want to get that A star. Absolute must. In an ideal world, you would do all the questions because they'll just give you more practice, more concept clarity. You do that, listen to me, you'll get an A star. Promise. So, with that, I'll see you in the next video. Thank you very much.